Let's make a 12-note series. And then a matrix. All right, so I'm going to use this random sequence website, random.org, I guess. I just Google searched it and to get our series. So I'm going to make the smallest value 0 and the largest value 11 for our 12 notes of the chromatic scale. And then this is the series I'm going to use. So click Get Sequence. All right, there we go. We have our note sequence, and we're going to put those into note names and then make a matrix. Okay, so the reason we're making a 12-tone matrix is to experiment with the compositional technique of 12-tone serialism. Serialism is a compositional technique that was pioneered by Schoenberg. And I've taken the 12 notes, 12 in number form, and that we randomly generated, and I've put them here. Now we have to assign letter names to these 12 tones. So we're using a system where C equals 0. So C is 0. C sharp or D flat is 1, and you proceed like that up the chromatic scale. F is 5, F sharp or G flat is 6. Remember, that's the halfway point, 6 between 0 and 11, so that's our tritone. G is always 7. Guess I ran out of room. A sharp or B flat is 10, and B is 11. And then if you were to keep going, you would go to 12, and it would be C, but we always keep it in a mod 12 system, which means our numbers are 0 to 11 always, so you would just be back to 0 after that as C. Okay, so now we can assign these to our row. It doesn't matter which version of sharp or flat you use when you decide, like when we get to 10, let's say. We've got to pick A sharp or B flat. Doesn't matter which one, but just keep it the same way in your matrix, whichever one you do pick. So 9 is A, C is 0, 5 is F, 10 is, let's go B flat, 3 is, let's go E flat, 2 is D, 6 is, let's go F sharp, 11 is B, 8 is, let's go G sharp, 1 is C sharp, 7 is G, and 4 is E. Okay? Make sure you have each note of the chromatic scale and no notes are doubled. And if you have 2 notes that are the same, like if we had an A here and an A somewhere else, then you've done something wrong. Okay, well, each note of the chromatic scale is just represented once and no more, no less. Okay, so now I've put my that first row with the numbers above, the letters below on some graph paper so we can make our matrix. You'll also notice I put some letters here in front of the numbers I. That's because I'm going to show you how to read this when we're done. The I means if you read this row going down, it's the inversion to row or column. And we have P going this way. RI, if you read up the matrix, is the retrograde inversion. And then if you read this way, it is the retrograde. So we have our initial series, which is the P9 series. It's 9 because A is the 9, the 9th note, up from C is 0. So that's where we get the 9 from. Okay, now we're going to do a trick where your first note here of your row, top left corner of the matrix, will be the same note across the diagonal of the whole matrix. So we're going to fill that in first. So just go diagonally down from the top left to the bottom right. So these will all be A's. There. Now make it easy on yourself and just work in half steps. So find where the note a half step lower than A is in your original row. So G sharp is here. So if G sharp here went to A here, then that means all of these for that row across will be a half step higher. So G sharp to A here. So I'm just going to make a little dash so I know which row I'm working on. Now I just take each of these notes and go up a half step to fill out the rest of this row. So C sharp goes to D, G goes to G sharp, E goes to F, back here B goes to C, F sharp goes to G, D goes to, again, use whatever one you use. So we used E flat, not D sharp. So we'll continue that. E flat, up a half step, goes to E. B flat, up a half step, goes to B. F up a half step, we used F sharp, I think, yeah. C, and we use C sharp, not D flat. And then A up a half step, we used B flat. All right, and then we're done. Again, you can keep checking yourself if you don't have any repeated notes. If you have each note represented, no less, no more than one time, then you've done it correctly. Okay, so it looks like we're good here. Now we can use this row to piggyback off of the next half step up. So find your G sharp again, and the only reason is because that's the note that's a half step below A, and then we'll raise everything up a half step from this row. So G sharp is here, and A is here. So this whole row will be up a half step from this row. So G sharp goes to A, F goes to F sharp, D goes to E flat, A goes to we're going up a half step, B flat, C goes to C sharp, G goes to G sharp, E flat goes to E, E goes to F, B goes to C, F sharp goes to G, C sharp goes to D, and B flat goes to B. And check, make sure we don't have any doubled notes. And it looks good. Now we take this row, we find the G sharp, and we find where the A is, and so that means this whole row will be up a half step from this whole row. So we keep going. B, I'm just going to start over here. B up a half step, C, D up a half step. No, we didn't do D sharp, we did E flat. Got to keep referring back to the original row, make sure you use the right enharmonic spelling. G goes to G sharp, C goes to C sharp, F goes to F sharp, E goes to F, G sharp already went to A, C sharp goes to D, B flat goes to B, E flat goes to E, A goes to B flat, and F sharp goes to G. And so you'll keep going like this. Then we'll find our G sharp here. Check no double notes. Okay, G sharp here goes to A here. So we'll go up a half step from this row to make this row. And you just keep going like that until it's all completed. Okay, so in the interest of time, I won't finish it up here, but do try to finish this one up at home. And let's talk a little bit about how to read this. So then you can start labeling it. So like I said, this is the P row, the original row. And so this would be whatever note this is in the mod 12 system, 0 through 11. C is always 0. You would put P 0 here. And so this is the P0 row. So you might be asked, this is the original series. What is the P0 of this original series? And so you would look at your matrix that you've already made the whole thing, and you would say, well, it's this. And so this would be P10, and this would be P11. Now, same thing with the eyes. Once we don't have a complete row on the eyes yet, but once we got it all filled in, you would read down from here, and we've already labeled, again, these numbers come from this number. Since E flat is 3 in 0 through 11, C is always 0. This is the I3 column going down. So again, if you were asked, here's your series, what is the I3? Well, then you would just read down from here, and that would be your I3 or inversion. Retrograde inversion. So the RI columns, you're reading up. Now you don't use, since we're going backwards on the retrogrades, you don't use this as your basis of the number. It's what the number is at the end of the column. So since that's 3, if you went backwards, it's RI3. Like that. So it's not F, which would be 4, it's 3 because this would, sorry, F is not 4, F would be 5. Since this is 3, this is RI3 as well. And you would read up for the RI3 row. So if you're asked, here's your series, what is RI3? You would make your whole matrix and you would go up from here, and that's your RI3. Retrograde, which is just a fancy R for retrograde, it's just a fancy word for backwards. So we do have some of these. So this P row, if we were to just read it backwards, that would be retrograde. So starting here, going that way. And the way you would label that would be, again, since we're going backwards, we don't base it off the G. It's whatever the number of the row is over here. So this would be the R0 row. So the R0 row would be G, B flat, E, B, D, and so on. And that's how you make a matrix. That's how you read a matrix. You can compose a whole piece using a matrix. You take your 12 tones, and now you've figured out every combination you have of those 12 tones that relates back to your original 12 tones. So none of these rows are just out of thin air. They all relate back to the original row, and that's kind of the point of serialism.